Hello. Glad to be here at Gaia. As the introduction said, I'm a data scientist. I've got a background in electronics, and most of my professional work is in the energy industry. So I particularly liked some of the talks earlier today. I'm also an active angel investor, particularly around the energy transition. So a lot of the themes that I've heard in the talks today really resonate with me. The title is Python, Natural Language Processing, and GPT. We've tagged this as being level 1. It's more about business and how to think about these technologies rather than us going through algorithms, code, etc. So it should be hopefully interesting for you, but not too taxing. We'll cover 4 topics. I'll talk through some foundational concepts, some of the fundamentals that I think are important about NLP. We'll then move on to looking at some applications of GPT, and then think a little bit about the roadmap. The audience I'm expecting are IT professionals, data scientists, machine learning engineers, and also entrepreneurs. And from the talks that I've attended today, I think that is the crowd for Gaia. The tag that we put on this talk was enterprise architecture. I don't know if that's a phrase that's familiar to everybody in the audience, but I noticed in the last talk that there was they used the term socio-technical. Enterprise architecture is all about socio-technical systems. It's about people, it's about process, it's about organization, and it's also about technology. And with AI, I think to make the most out of this technology, we have to have a socio-technical view of it. The term comes, we could trace the term back to post-war Great Britain. The government invested huge amounts of money into automation technology in the mining industry. Productivity went down. So they brought some clever people in to have a look. And the reason was that the technology wasn't working with the people. The people weren't working with the technology. The change in the organization wasn't designed properly. So the term socio-technical systems was coined. And that was from the 1950s, which I believe was when the term artificial intelligence was coined. So we've got a little bit of history here that is important for us moving into the future. So we've seen the rise of LLMs, and I like to use this mental model of a tree. The roots are in data science. And the trunk is natural language processing. And as you climb up the tree, it starts branching out into various technologies. The one that seems to be getting the most traction is GPT. And I expect that a large part of this audience knows more about the technicalities of GPT than I do. The thing that's put GPT on the map really is OpenAI and ChatGPT. When the product was launched, that was when I really woke up to natural language processing. Up until then, all my work in data science and AI was around computer vision, digital signal processing, time series analysis. I hadn't really looked at natural language processing, but when ChatGPT was launched, there was a light bulb moment for me, and since then I've been trying to learn as much as I can about it and use it in practice. In the model, the green lines in the model are the leaves and the fruit of the tree. And organizations that want this technology, that are looking for this technology, that they want to bear the fruit of the technology. They're not interested too much in the technicalities. They want the business benefits. Another model that we have to think about is the building blocks. And you know, there's a selection of Lego pieces there on the screen. This is by no means exhaustive. This is just the pieces that I'm familiar with. So I work a lot with OpenAI and their API. But you know, think of that. I think of that as being at the top of the pyramid. To get the most out of it, you need to put other building blocks around it. Also working in natural language processing, you need to understand technicalities like tokenization, lemmatization, and so on. Vectors play a huge part. So if you're working in NLP, you're going to be working with vector databases. Lots of people will be experts in particular parts of the technology. So vector DBs, for example, there are many vendors out there. The word map there, it was taken from Wikipedia. I asked ChatGPT to build the word map of vector DB vendors, and this is what it gave me. You drill into the vector DBs and you learn about nearest neighbor searches, the algorithms, the hashing, and so on. There's lots of technicalities. Geeks like me and a lot of the audience, you love this stuff. But the people that are paying for the projects couldn't care less. They want the business benefits. So this is one of my key takeaways. You know, it's important to understand the technology. It's important to understand what's going on under the hood. But never forget that the end customer, the people that want the benefit of this, don't really have much interest in the nuts and bolts. So, what does Enterprise GPT look like? From my point of view, the RAG model is the quintessential architecture for the enterprise. Well, why is that? I think everybody here should understand that enterprises don't want to be sending their data to OpenAI, right? There's privacy concerns and confidentiality and intellectual property concerns. Also, you know, OpenAI doesn't know about the HR policies in any companies, so it can't answer specific questions. You get general answers from large language models. So I think the RAG model is the quintessential architecture for the enterprise. And when you drill into the RAG model, you see lots of sources of data. Enterprises have got data everywhere: data lakes, data warehouses, data silos. There's lots and lots of data. They also have a lot of not very interesting concerns for engineers. And I call these fatigue duties. They're fatigue duties because, well, maybe they're a bit tiring and a bit boring. It's a term from the military. Soldiers have fatigue duties. It's anything that a soldier has to do that isn't combat. And for engineers, you know, these sorts of things, security, compliance, assurance, they're fatigue duties, but they take up the majority of the work in an enterprise. I'm a very keen student of Fred Brooks. One of his works, The Mythical Man Month, seminal work in project management of software. And I think the principles from The Mythical Man Month, which was written in the early 70s, still applies to the development of AI solutions. You know, small teams of developers can produce a lot of work, but in the enterprise, there's layers and layers of these extra complexities, these extra duties that need to be brought, and I don't see that disappearing. But I think that the large language models make the work a little bit easier and a little bit more achievable for smaller teams and smaller organizations. As I said, in your RAG model, there's lots of sources of data, and data management and governance is a huge issue for enterprises. Now, as a data scientist, I'm very familiar with the 5 V's, and I'm also familiar with this concept that big data is a relative term. You know, every enterprise has a different notion of what is big data. I do work in IoT, in automotive. So if you start thinking about how much data is streaming through a modern vehicle, particularly one that involves autonomous driving, it's quite mind-boggling. I do work in the energy sector, so order to cash processes. There's lots of data streaming in to the business, but it's orders of magnitude less than in an IoT type application. Work with document libraries is also quite interesting. Again, possibly an order of magnitude lower in terms of the volume of data, but in enterprises that have legacy documents, you know, to them it's a big data problem, and to us as engineers, to solve the problems, we have to find the right tools and manage and govern the data appropriately. The kinds of application domains, there are many, and personally, I take a great interest in sales and marketing, manufacturing, and legal. And when you look at it from a technologist point of view, they can seem very similar. But as an earlier speaker noted, when you look at these domains from the practitioner's point of view, there's lots of nuances come into play. And I think one of the big changes that generative AI is bringing to software and IT professionals is that they're bringing the engineers closer to the business practitioners. There's not the layers of business analysts and so on between the developer and the business practitioner. So I think engineers with domain knowledge are super powerful. This is the future of engineering. You need to have the domain knowledge, and you need to be able to understand the context of the work that you're doing with this amazing technology in an enterprise. Personal productivity, I think, is also an important topic for IT professionals, and I've used ChatGPT quite extensively for documentation, and I find it's a very helpful muse. Overall, I would score it as a B+ assistant in every topic. This is the power of it. It knows every topic, but it doesn't know topics to A standard. It's always kind of B+. I've found personally that managing chat history is really valuable. I geek out and I extract my ChatGPT history and put it into Elasticsearch, so I can get some insights as to conversations I've had months ago with my co-pilot. I'm also finding that content and product workflows are still evolving over and above the use of AI. Tools like Mist and Tipst, I find fit into that AI, generative AI workflow. So I think we've got a long winding road ahead of us, and I see generative AI absolutely reshaping the enterprise. I think of Python as being an important component of that over the next at least 10 years. It's currently the lingua franca of AI. I have a notion that more and more people will become programmers. Programmers are not going to go away because of generative AI. In fact, it's going to be the opposite. There's going to be more need for programmers. I think that programming is going to become accessible to business people, to non-technical people. So we're going to have a wider church of people programming, and the AI tools that we have will help that. Are there any silver bullets? Well, again, this is a work by Fred Brooks. I don't think that generative AI is a silver bullet. I think we're in the business of complexity, and that complexity is going to remain. The next 10 years is going to be an interesting place for us to be working. One last thought before we go to Q&A. In fact, this is me asking you a question. What the hell is AI? I don't like the term artificial intelligence. There's lots of problems with it. Intellectually, also, does it pass the test of you having a discussion with your grandmother? How do you explain to your grandmother, I work in artificial intelligence? Yeah, it's a technology, it's a tool. I would try and explain, well, maybe not to my grandmother because I'm of an age where I don't have a grandmother, but to my mother, I would explain that I work in accelerating innovation, or delivering awesome impact, or delivering advanced insights. And every one of you will have your own version of AI, but hopefully not sticking to that term artificial intelligence, which I've got several problems with. I think everybody here is not confused about AI, but if you are, there's a couple of links there. Richard Susskind's got a great book, and also Freakonomics had a great podcast series about AI a year or so ago. I mentioned earlier about using ChatGPT to create content, and I wrote a book with the help of ChatGPT, and I have a copy here. I think that going through this process of writing a book kind of opened my eyes to a lot of the limitations of generative AI. So there is very much still a human element in doing creative works, but the generative AI really is a huge help. There's no way I could have written this book and continued working without generative AI. So I'm a huge fan. I think I'm now ready to take questions.
Thank you. Neil, thank you so much for the presentation. Really, really interesting. Yeah, let's open up the room for some question. If there's any questions from the audience, now is the time. I'm going to start off with a question from me. So looking back at your previous work and your previous experiences, have you seen any, you were mentioning both the energy sector as well as automotive. What are the main differences or similarities between these industries when it comes to adoption of AI and maybe specifically generative AI?
Well, I think comparing automotive and energy is quite interesting. These are very highly regulated industries that are quite slow moving. Just as an example, I worked on a project with Volkswagen in 1999. It was a concept car, a multimedia concept car. So we built a proof of concept in 1999, and you didn't see the products that we had prototyped coming to market until around 2016. The utility sector, the energy sector, is even slower. So in these industries, they have challenges with innovation, but at the same time, it's a little bit of a paradox. They embrace AI. You can't. You probably wouldn't find an energy company that isn't doing predictive maintenance with AI, that isn't doing commodity trading with AI. So there are pockets all around in these industries, but the vision that a lot of startup entrepreneurs have that they can disrupt these industries with new technologies, I think, is a little bit optimistic.
Right. And as a quick follow-up on that, what are the primary LLM or generative AI applications that your clients are mostly looking for or mostly interested in these days? Is it the RAG application, or is it something else, in your opinion? I'd see RAG applications. I see agents on websites to do customer service. I see sentiment and intent classification work, with companies that have a customer service backlog. They're getting overwhelmed with queries from customers, and they want to clear that backlog, and they see generative AI as a solution to help clear customer backlog. Right. Any other question from the room? Yes, over here.
Thank you very much, Nick, for a very good presentation. Quite thought-provoking. I have a question about something you said, which was a little bit... I work as a teacher, and a lot of students are worried about, why am I learning programming? am I going to have a job by the end of my education? And you just mentioned the opposite, that no, we will need more programmers. I don't know, could you elaborate a little bit on how you think about that? How should I respond to them when I get that question next? And my second question is about risk and insurance. Yes, it's very useful. That's something I've maybe missed during this session here. When you dedicate work to AI in the same way that you mentioned there, and several use cases, who is responsible? I mean, we discuss about risks and legalities and issues like that, but that question is still something that people, as far as I understand, give different answers. When something is wrong to a point that we need to share responsibility for what has gone wrong, are you or the AI?
Just a quick, your question was fantastic. Can you pick one of them to be answered, because we do need to
just the first one, maybe.
The first one, yeah. Great.
Yeah. Two great questions. The first one, from a personal point of view, it reminds me of the challenge that I had when I was a young man. I was into programming, and I looked at university courses and college courses, and they wanted to teach me Pascal. And even at that point, I knew that there was no point in learning Pascal. So I decided that, well, I'm looking for a career in computing. The electronics, the fundamentals of electronics is mathematics. That's not going to change in my lifetime. I'd be better studying that than studying Pascal. So I think for students, the basic advice is learn fundamentals. Learn the fundamentals of business. Learn the fundamentals of software engineering. There is work for software engineers, but you know, to coin a phrase, I think from Gartner, you know, AI isn't going to replace people. AI is going to people that use AI are going to replace people that don't use AI. So students need to learn a way of working with AI based on good fundamental groundings.
Great. And with that, we thank you so much, and it has been an honor to have you here. Big applause.
Thank you.
Thank you. Thank you.